Welcome to Hopper. This is the channel intro video. It's fairly long, it covers a lot of ground, and there'll be links at the end to specific videos that are where I reference things like installation, for example, or the language. Anyway, let's get started. Hopper is a modern semicolon and curly brace language. Similar in that regard to, say, very C-like. Instead of a main, there's you could say Hopper like that, which is optional. So that's your main program. Your main, your entry point of your program is main. It's similar to C, but it's also similar to Java or C# in that, or Python in that it's garbage collected. So it's got a managed heap, which is kind of nice for microcontrollers. It's, obviously also designed to run on small devices like microcontrollers, as you can see from the video. It's running on a Raspberry Pi Pico there, and a clone, and other devices. I'll switch just to Windows for now, just to start on there. This entire development environment is on Windows. It's all written in Hopper. So the editor is written in Hopper, the toolchain, preprocessor, compiler, optimizer, code generator, disassembler, they're all written in Hopper. They all run on Windows in the Hopper environment. This editor is written in Hopper. There's a full debugger written in Hopper. We're going to start by just running on Windows with the usual hello world. So if we go hello world, right, and now all the shortcuts are on the menus, so you can see what they are here. They're very similar to other development environments like Visual Studio. So we can build that, and now it tells us it doesn't know what hello world, what println is, right? And Hopper has the concept of units. So there's some system units, and they're all, the source file, the source code for all of this is included. It's all on the GitHub repo as well, but it builds from source every time. So there's a unit called screen, and in screen, I just double clicked on that to go to where it is, and I could do it another way as well. If I now if I build quickly, built, right click on something, and it'll take us to the definition as well of all the different println versions. A lot of Hopper is written in Hopper, so there's the system versions. These are actually implemented in the runtime, whereas all the variations are just written in Hopper. And the optimizer pretty much deals with that. So if I build that now, it's successfully built. And I'm going to go back to the console to run it. So it's called test, I believe, yeah. And there it is, printed out hello world as we would expect. So this is running on Windows, which is all great, but there's lots of development environments for Windows. And this development environment, our intention here is to run on microcontrollers. It's optimized for small devices. So how do I make that work on the microcontroller instead? Well, if I look at under the source folders, under library, under boards, there's a lot of boards defined. So I just need to include a board. So let's go back to our program. And for this demo, I'm cutting and pasting from some code I got on the side here just to make it quicker. But the board I'm working on, is this board today. And let's have a look at the star of our show. So that's our board today. It's a SparkFun sort of micro format board, RP2040 board. These are all RP2040 boards, all very similar to the Raspberry Pi Pico. And then there's one other change I'm going to make, is I'm going to change that to right for a reason that'll become obvious soon. So now when I build, if you look at the bottom of the screen, you get these progress. It says right lines not defined. Right, because I put an extra L in it. There we go. So now if I right click on write line. Let's see where it is defined. It's defined in a, if you look on the top right here, this is the current file you're in, and that's the file you came from, or the project file. And I can click on these to navigate as well. And I'm in the system IO unit. And IO is a weird mix of screen and serial port, right? Because the easiest thing to get up and running with on these devices is going to be the serial port. And that's where we're going to go to by default. So let's go back to where we were. And that's what that's going to do. So if I build now, I have more options. I've got the ability to launch the debugger. So if I press F5, the title bar at the top changes to green. I'm now in the Hopper debugger. And I'm debugging directly on the microcontroller. If you look at the bottom, it knew it was generating code for a microcontroller because I use microcontroller units. So it made an Intel iHex format of the binary and already has uploaded it to our device. Let's quickly just move that screen because this, let's go back. The top black section here is the serial console connected with the remote device. The bottom section is the watch window for the debugger. So let's first just see what this does. I'm just going to hit F5. So it ran the program exited, reset. So when it's finished running the program, because it finished and exited, it resets the session so it's ready for another run. It's right at the beginning again. And if you look at this window up here, it's output that text to the serial console, right? Hello world to the serial console. All right, now let's move the screen again. And let's do that again, but this time we're going to step in. So now, again, all the commands are on the menus and you can find the shortcut keys. And like I said, they're similar to other development environments like Visual Studio. So I'm going to use F11 to start now. And there we go. It's got one global variable in the watch window. Text scale is 1 because it knows that that's related to drawing. It's actually related if you're drawing to the screen rather than to the serial port, but we'll get to that. Step in. As I said, a lot of Hopper is written in Hopper. So writeLin is made up of 2 other APIs. So now we call write_s. Write_s is made up of something else. It's going to step through. So this for each is similar to Java or C#. It's just iterating through a collection. In this case, the collection is a string. Other collections would be things like dictionaries or lists or arrays. Right now, my debug output is in hex. I can go up here and say switch it from hex, and it'll change it back to not being hex. So I can see in here my call stack. I got called from the main method in Hopper, hello world. And then I called this writeLin, and now I'm about to step into another one. So let's go F11, and you can see my call stack went one deeper. It's now got the first character, the H. Echo to LCD is false. We'll get back to that in a second. That's actually, this IO module can be made so that the output will go both to the serial port and to an LCD device if you have one. We haven't configured that LCD device yet, so we can't talk to it. So that's echo to LCD is going to be no. And we're done. And we get our H, our first H is now showing up in our window here. And I'm going to F10 through these now. So like F10, you can see hello world appearing there slowly. All right. So that's, and you can see the debugger here showing you where you are. So unlike the Arduino environment or the MicroPython environment, this is a full debugging experience without any extra wiring or debug hardware. It just, via your serial port, you have a full debugger and you can step through. And you can put breakpoints in as well. And you can double click on everything that you think you should be able to double click. So we can put a breakpoint over there when we hit the writeLin, and then hit F5 and it'll go until it gets to our breakpoint. It's stuck on our breakpoint. Now the gray bar is the current. And now I can step into the writeLin where it's just going to write out a new line. Let's carry on stepping. So full debugging experience. Running on Windows, super simple install. There are no dependencies. You don't have to install anything else on your machine. You just install the Hopper environment and you're good to go. Okay, And yeah, the way you get Hopper onto your RPU 2040 device is there's some pre-made UF2 files that you just put your device into boot mode and just drag and drop the UF2 files onto the device, and you're good to go. And like I say, we support about 40 boards. And you can see that in the releases on the GitHub. And there'll be links to this in the description and videos at the end of this one. Anyway, Alt F4 to exit the debugger and go back to the editor. Now, let's make this a bit more interesting. So, we know we've already got our device, but as we can see from the video, there's a screen plugged into it. So let's take advantage of that screen. And the way I've done this is there's two parts to a screen. Well, typically two parts to the screen. There's the actual device, which in this case is an Adafruit device, right? And then if you go into that, that's the device driver. Again, double clicking on things to travel. And it uses a display driver, which is a generic TFT driver. So you double click on that, now we're in the display driver, and the display driver uses display, which has got all the usual display features like drawing lines and drawing text and all that, right? How do I get back to where I was? Control backspace, Control backspace. So you can jump forwards and backwards in the editor quite easily. That's how projects work. You don't ever define a project. Your project is your main file and whatever it includes. Simple as that. And the optimizer, the compiler and optimizer don't include unused code. So your program is as small as possible. It doesn't matter what you included in the compiler. Okay, so now we have we have a device connected. We do have to do a little bit of work to initialize the device. So typically, it's going to be device driver begin. So you're going to have something that looks like that, right? So let's build that and see what happens. So bottom of the screen again, compiling. Oh, it's got a problem. So because I'm trying to write text, oh no, because I'm using a device that is a text display, I should include a font. And again, we've got under the libraries, there's a whole selection of fonts. You can only use one at a time right now, but yeah, let's include a font. So if you go and look under the fonts folder, you'll see there's a selection of them. So let's try again. There we go, success. So let's load up that, and we're going to step through and see if we successfully initialize our device. And it thinks it's successfully initialized the device. It's still just writing to the serial port, not to the device. But I know it hasn't successfully initialized the device. And this is because there's a bunch of pins connected here, to the device, a bunch of different pins. And the device driver can automatically guess a bunch of them. So if we right click on begin, we can go in and see it can automatically figure out that it's a SPI serial interface device, and it can automatically figure out defaults. So use the defaults, assuming you're on SPI 0 controller. But it can't, the DC pin, there is no default for. So the data versus command pin on a TFT device. So you actually have to set that one up manually. So it's whatever you wired it to on the board. So whichever you can wire it up to any general purpose IO pin, and mine's on pin 28. So let's try that. So that's now actually hooked up. And now instead of write-len hello world, or there's two ways we can do this. We can make it go to both if we say echo to LCD, or we can just change it to println like that. And println will go to the to the screen rather than to the serial port. So if we want to check that that's true, launch the debugger, we can see our serial window, our serial console over here. And now if I step through here, F10, so it's hook up that I can step into this F11. It's stepping into a property, and it's going to change from 10, what it was there, 10 to 28. So if I, there we go, it's set up to 10 now, begin. It's successfully, and because I'm printing, it knows that the related global variables for printing, if I fade across, are default background and foreground colors. And these look better in hex. So the default foreground color is a sort of a green, and the default background color is black. Right. So now if I F10 over print, let's see what happens. Well, on our device, you can see some yellow text appeared. So it did print to the device. And if you look in the serial console, nothing came to the serial console. So that's kind of what we wanted. And let me do something else by way of demo. So if I do another one like that, okay, I built it, and then I can run it outside the debugger as well. If I control F5, it'll just run it in the console like that. And then we can see we've got 2 lines of maybe I can get that a bit closer. Yeah, 2 lines of hello world. And you can see what our problem is here. It's too bloody small to see on the screen. So let's make it a bit bigger, shall we? So if I then go, I'm going to put a blank line after that first one. So I'm going to put a blank line after the first one. I'm going to change the text scale to screen to 2, and I'm going to change the color to red. And now something obvious is going to happen again. So I built that, and now let's get in the debugger and just F5 to run it. And there we go. And it made a bit of a mess because it's still got my second original sort of greeny yellow color there. So what do I want to do? So I want to clear the screen beforehand, and I'm deliberately doing this. This is not going to work the way we expect. So I do that. And then I F5, and I'm going to get exactly the same result. Yep, didn't clear the screen. Okay, so why? And this is kind of handy. If you right-click on clear, you'll see which clear is being called. And it's the clear in the serial port. It's clearing the serial I/O, sending a form feed to serial, which is the same as clearing the terminal window. So this brings us to another thing that's about units, and that's that you can fully qualify things that have conflicting names by doing that. So I mean, you could do them all to make clear what you're doing, like that. So if there's an ambiguity between calling 2 different methods, which is quite common if there's no arguments to the method, then you'll do that. So let's F5 it again, and now that second line should disappear. Cleared the screen. Yeah, and there was some noise at the bottom of the screen that got cleared as well. So we can see there that we don't have the second line. Well, while we're on a roll, let's add a third one, shall we? Let's put another blank line, but I want the blank line to only be one scale of 1 high. And then I'm going to add a third one here. So a full editor has got, like, unlimited undo, all that. So I just Control Z. So let's do scale of 3. We might actually be able to see this on the screen and use another screen. Again, you want to go see where this color is defined, just right click on it. And denim sounds like a better color. Let's do that. So it took us to the system color file, and our colors are in RGB 444, which is handy because it leaves the top 4 bits so that I can use the top 4 bits for other things like flags to say this color means invert. Anyway, Control backspace to go back to where I was, and I'm going to use, and you can qualify it as well in case there's more than one denim in your system, right? Okay, let's do that again. and launch the debugger and run. There we go. It looks more like denim on my screen than it does on the video, but so what? All right. So, and I'll just one more time demonstrate the debugger just because it's kind of cool. So let's put some breakpoints in here so we can stop when we get there, stop when we're going to set that. And it's restarted, it's reset because it finished. And then you just F5. And it'll run into, and the gray bar means it's stuck on the debugger here. So we can see on the screen we've got one tiny little yellow hello world. So as soon as I press this, I should get the red one. F10 to step over that. And I get the red one. And then I'm going to F5 to the next breakpoint. And it's going to set full color to denim. Let's step into that with F11. Since it is a property, we can just step into it. F11. So there it's going to go and get denim, which is that hex value. And now it's jumped to the next property, which is the one it's going to set. So the current value of foreground color is red, RGB. So F is red, and it's going to set it to denim. And now if we press F10 through that, we're going to get our last one out. All right. And I think that's enough of a demo of the debugger and the sort of getting started hello world nature. There, like I said, there'll be links at the end to more about the language and more about the debugger and more about installing this. So now I'm going to switch back to just using the console again and show a different demo. So let's do that. We'll fade to that one. And MCU shell. I've already preloaded all this, but so another thing that device has is an SD card. You can't actually see it on the side of it. There's a little SD card in there, and Hopper mounts SD cards into your existing file system, your existing flash file system. Oh, I should have included that as well. I think I can do it. There's another link to another demo on that. But so I've built the shell. So now you might have seen this big black screen where I'm wandering around. So if I go like dir slash -s -f, that's the full directory of my system with all the source code. So this shell here is actually the Hopper shell, which is sitting inside Windows. So it's running in its own shell. It has its own rules about what file names and paths should look like. Like there's no spaces in paths in Hopper, and whether they're case sensitive or not. And so it's designed so it works the same everywhere, which is kind of tricky, since you have things like the Mac OS, which isn't the same as Linux when it comes. It's like a case insensitive version of the Linux-like file system. So that's why I decided to make my own. Anyway, the MCU shell is a version of the same shell that's made to run on the devices. So I've uploaded it, and how do I get it to run in a way that I like? So if I go to the device and I just hit the reset button, that has successfully run it. Now if I go to my terminal, I think I'm already on the right port. Yes. So if I exit out of here with Alt F4, you'll notice that this terminal is blue, but this terminal is the serial port and it's green. So if I do another dir-s-f, that's what's on the device, and it's actually all on the internal on the built-in flash on that RP2040 device. And I've preloaded this all onto that flash so that I can do this demo. So it's got all the stuff you expect in a shell. Oops. Let me reset that. I did something. I obviously confused it a bit. Having technical difficulties here with my video capture tool. Okay, yeah, my video capture tool hung on me. So let's get back to where we were. So cd bin dir. So yeah, it works like you'd expect a shell to work. And this is all running on that Pi Pico device. And I have some demonstrations which are kind of so I have a Mandelbrot demonstration that was taken from Gordon Henderson's Tiny Basic, but it's a nice demonstration to do across a serial port, and it's also a good one to benchmark a significant difference. So let's run it. So that's what Gordon's Mandelbrot looks like, and it's written to run in BASIC, which is convenient, and it takes 900 milliseconds. 924 milliseconds. This is the version that's written in Hopper. Hopper is sophisticated enough that you can write other languages in Hopper. So I've written something called Tigger Basic. So this is Tigger Basic written in Hopper, running on the RP2040 device. And inside Tigger Basic, I also have the same Mandelbrot example. And if I list it here, there it is. There's the Tiny Basic, Gordon's Tiny Basic original version of this Mandelbrot. So if I run it here, that's 1.3 seconds. It's only like 50% slower than if it was written in native Hopper, and it's pretty darn fast, compared to other platforms. Talking about other platforms, so I can exit out. So yeah, I can just do, print hello world. It's a good old regular basic, or if I could spell. Or I can say new program 10 for I equals 1 to 10, 20, I, 30 next I. Right. And I have a couple of other obvious programs here, like if you load, this is the Byte Magazine benchmark for BASIC, and it's a prime number sieve, and it's going to run 10 iterations here, and this gives us a really good idea of performance. It helps me to benchmark whether I'm improving the performance or not over time. Let's see if I can fix this one. Still trying. Okay, so if I switch this back, what's running in the background here on that screen in the background is the TFT benchmark demo with all the different graphics commands, and it's very similar to the one from Adafruit that runs on the that's written in the Arduino IDE. And the overall speed in the Hopper platform compared to C, so this is Hopper compared to compiled C, is that demo runs twice as fast as the C, which is unbelievable. The one place there's an exception is where you rely on drawing things pixel by pixel. So text draws slower in Hopper than it does in C, and actual lines, so that text screen that just came up on the video is slower. And these lines are slower than if they were in native C. But the overall demo with everything combined is twice as fast in Hopper as it runs in Arduino. And Adafruit's libraries are awesome. You should definitely support Adafruit and buy the devices. For example, this device here, which is this little LCD with the SD card in it, that's an Adafruit device. Right, switching back to the full screen. Okay. So yeah, a language written in Hopper running on Hopper, pretty cool. So we should write other languages. There's one guy there's a Discord channel or a Discord server for Hopper, and one of the guys on the Discord server is interested in writing a fourth implementation in Hopper on these devices. If you're interested in getting on the Discord server, let me know, and I'll send you an invite. Anyway, let's exit out of here. And let's go back to that Mandelbrot sample. So, like I said, runs about 60% of the time it took in the basic version, but you can do more because you can change the speed on the fly. So I've changed the speed of my RP2040 from 133 megahertz, which is the default, to 270 megahertz. And up arrow, Mandelbrot again. Yeah, it's twice as fast. So I've been playing with overclocking and seeing. I've also played with how overclocking affects power consumption. So I've got a video on that as well. And stable overclocking, so I can switch back on the fly to a slow speed and then run the Mandelbrot on the slow speed. Now I'm running at 48 megahertz, and now it takes a lot longer, but the power consumption is less and the heat generation. Anyway, let's set back to our default speed. There we go. Yeah, all in Hopper, and this is in a console written in Hopper, running on the device. Anyhow, I think that's probably enough. What have I missed? Spoke about that. Oh yeah, like I said, I've got on my notes here 45 boards supported. The type of displays that I've got drivers for currently are TFT displays, OLED displays, e-paper displays, a lot of wave share devices, a lot of Pomeroni devices, and a lot of I've got SparkFun devices, Adafruit devices support. And then one of my favorite microcontroller boards in the RP2040 form factor is the Challenger from iLabs. I have one on hand. Yeah, so that's the iLabs Challenger, and you see that little bar at the end, Wi-Fi. So this board here, it has a USB-C connector. It has a reset button, which are two things the original Raspberry Pi in the background doesn't have, and that's the original Raspberry Pi in the background here. So this Challenger board, I support their the iLabs logging device, which has got a real-time clock on it, and SD card, and I support their Wi-Fi devices, and I'm busy writing drivers for their LoRa boards. So yeah, 3 different variations of a real-time clock support, 3 different chips supported. SD card support. So when you mount an SD card on your device, it just sits in your file system under a predefined folder called SD. Do I have it on this machine? This device? No, don't have it mounted. Oh, maybe I can just mount it. Let's try. Yeah, failed to mount. Maybe I don't have a card. But you can just mount the card. What if I can do that if I reset? So I exited from the shell, and then if I restart here, and then run the terminal, and just mount it now. No, I'm missing something to mount the card. It maybe just I haven't defined the pin or something. Anyhow, you can mount the SD card into the file system and then use it, and it's a FAT32 file system on the SD card. That's it. So this has been a long video. Most of my others are much shorter, but this is the intro video for the channel, which is telling you all about this language. I've had it running I've did a hand-coded assembler runtime for 6502 machines last year. Busy reworking that to use what I call the portable runtime. So the runtime that's running on these RP2040s is actually written in Hopper and then translated with a Hopper to C translation utility, which is also written in Hopper. And then I build in the Arduino IDE and make the UF2 files there. I'm going to do something similar for 6502 and Z80 soon, and there's a sort of I'm with my experience last year getting it running on the 6502, like I managed to get things like Tigger Basic working with a 8-bit stack pointer instead of a 16-bit stack pointer. Everything is very 16-bit in Hopper, so most of the value types are all 16-bit, which means float and long are not value types, they're reference types, and the built-in reference types are strings, obviously, lists, dictionaries, arrays, and then there's also a record type, which is a reference type, so a structured record type where you can include other types inside your record. But anyway, yeah, I'm going back to doing the minimalist tiny hopper again, and making that, this time I'm writing it in Hopper and doing a code generator for 6502 and for Z80. But that's going to take a couple of months. It's my current fun project. If there are boards or devices that are not well supported yet, or that you're having trouble getting working, again, reach out to me and I'll send you an invite to our Discord server so that we can converse. I look forward to your feedback, and go ahead and click on one of these links in the end of the video and go and learn more about Hopper. Cheers.